So I accidentally clicked stop recording instead of pause. That's why I have to make a new or second video, and I didn't want to reshoot all of it. So you guys just have to deal with it. But I ended the last video just saying like how many terms, if they ask you how many terms did it take for us to get that total. So you just count them. 1, 2, 3, 4, 5, 6, 7. So the first 7 terms, the sum is going to be 2,186. All right, so this one's saying now let's try the formula method. This is going to be a lot more time consuming. So on this particular, if I had the choice, I would go with the addition method. If it says like you got to use the formula method, go for it. But I think the addition method is easier, especially since we didn't have to continue it on for that long. All right, so anyways, let's look at the formula method. So first of all, if I want to use the formula and I want to find the sum of the first n terms, which is a, and then it's 1 minus r to the n over 1 minus r, then I need to know what the a is, which I know the a is 2. I need to know what the r is, which we know is 3, but I don't necessarily know how many terms there are. If I hadn't done this method, obviously we know there's going to be 7, but if we hadn't done this method first, then you would need to write an explicit rule. Explicit rules let you find the nth term. All right, so I'm going to say f of n equals, and our first term is 2. And then we're going to say times 3 to the n minus 1. Now, if you're wondering, like, how am I sure that that is n minus 1 and not just n? So if I plugged in a 1, 1 minus 1 is 0, and 3 to the 0 is 1, and 1 times 2 is 2. All right, so that's why I know that it's n minus 1. If that was just an n and I plugged in a 1, so 3 to the first would be 3, and then 3 times 2 would be 6, which wouldn't match up with that first one. All right, anywho. So let's figure this out. So we know that the last term is 1,458. So I can say 2 times our rule, and I can solve to figure out what the n is. So first of all, I'm going to divide by 2. That's going to shrink my values down. So then we get 700 and, what is that? 25, 20, 29 equals 3 to the n minus 1. And so again, like you could just grab your calculator and you could say 3 to the, put parentheses around it. I don't know if you guys can see that well. And then you can plug in, like I can plug in a 1 for the n, but I know that that's not going to be 729. So on the graphers, I'm going to hit second enter. I can backspace, and I can plug in a 2. That's not going to be it. So I could keep bumping it up. Or I could see like 3 to what power? Let's say 3 to the 5th and see if it's 729. No. Let's try 3 to the 6th. No, we already know it's a 7 because we did it on the last one. Oh, I'm sorry. Let me go 3 to the 6th is 729. So I could write it this way. So 3 to the 6th is 729. And if you have the same base, then you can just set these equal to each other. So 6 equals what number minus 1? And we get 7. So now I know that the 7. And now I can plug all of that in. So the first term, so the sum of the first 7 terms is going to be the first term, 2, times 1 minus our 3 to the nth term, which is 7, over 1 minus our r, which is 3. So I'm going to get 2. I'm going to do 1 minus 3 to the 7th over negative 2. I have to be careful with how I type this into my calculator. You guys might be able to type it in a little bit better. So I'm not going to do the 2 first. I'm going to do the 1 minus 3 to the 7th. Where's my, there we go, jeez. Okay, so that's my numerator, and then I'm going to divide that by -2, and then I'm going to take it times 2, and I get that 2,186. Now let's compare the two methods. Here was method A, the addition method. Formula method, I had to do all of this. Which one seems like the better method? This one. All right, but we'll keep practicing writing their rules. All right, so it says determine how many, that should say how many terms. Yep. The geometric series has, and then find the sum. So again, let's look at, we've got -3 plus 9 minus 27. Figure out what are they doing. So from term to term, they are multiplying by -3. So let's take 27, or -27 times -3, and we get plus 81. And then we're going to say plus, we're going to take that times -3, and I get -243. I'm going to say plus, I'm going to take that times -3, I get 729. Then I'm going to say times -3. So I'm going to get plus a -2,187. Yikes. And then I'm going to take that times -3. So I get 6,561. And then I'm going to say plus, I'm going to take that times -3. Okay, so we get -19,683. I'm going to take that times -3. And I get 59,049 plus, I'm going to take that times -3, and I get that -177,147. And then I get to just type it all in and add it up. So we're going to say -3 minus plus 9 minus 27 plus 81 minus 243 plus 729 minus 2,187 plus 6,561 minus 19,683 plus 59,049 minus 177,147. There we go. There's our total. -132,861. And how many terms did it take? So just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11 terms is going to give me a sum of -132,861. All right, so now it says let's go with that formula method again. So remember, for our formula, S of n, we need to know A, we need to know R, N. So we already know that the A is -3. We already know that the R is also -3. We just don't know what the N is. So to find N, set up an explicit. Okay, so we're going to say f of n equals -3 times our -3 to the n minus 1. And again, if I plug in a 1, 1 minus 1 is 0, -3 to the 0 is 0, I'm sorry, -3 to the 0 is 1, and 1 times -3 is the -3. All right, so we're going to plug in the last term. So the last term was -177,147. Okay, I'm going to divide both sides by -3 to shrink our value down. So -177,147 divided by -3 gives me 59,049. 49. Okay, so then I can grab my calculator and I can type in -3, raise it to, and I can just start guessing numbers. Let's say I plug in a 5. 5 minus 1. Nope, that's way far off from that. So let's say I try 9. Okay, I'm getting closer. Say I plug in a 10. Nope. Let's say I plug in 11. There we go. So I know that my n is 11. And now I can plug that in. All right, so the sum of the first 11 terms is going to be the first term, so -3 times 1 minus, now be careful here because your r is -3 to the n. You cannot simplify that double negative just yet. Actually, our 8, I'm sorry, the n was 11. Okay, and then we're going to say 1 minus, again, our r is -3. All right, so we're going to say -3, and then we're going to say 1 minus -3 to the 11, but all of that's going to be over 4. And again, when I go to type it in, I'm going to type in the numerator first. So I'm going to say 1 minus a -3 to the 11th. I'm going to divide that by 4. And then I'm going to take it times -3. And I get that same sum that we had earlier, -132,861, and it was the sum of the first 11 terms. All right, let's look at this next example. So it says, write the finite geometric series from its given description and find its sum. So again, for the sum of the first n terms, I'm going to take a times 1 minus r to the n over 1 minus r. I need to know what the a is. All right, so it begins with a 1, so there's my a. It has a common ratio, so the r is 1/3, and then the n is 5. So the a is 1, the r is 1/3. So we're going to say 1/3. I'll put that in parentheses. You don't necessarily need to keep writing n, but our n is 5. And then we're going to say over 1 minus our r, which is 1/3. I'm just going to clean mine up a little bit, so I'm going to say 1 minus 1/3 to the 5th. 1 minus the 3rd is 2/3. And then I'm going to grab my calculator, and again I'm going to type it all in. So I'm going to type in my numerator, 1 minus, my r is 1/3 to the 5th. I'm going to divide it by 2/3. And then I'm going to take that times 1, which isn't going to change it. I'm going to turn mine back to a fraction. So I get 121 over 81. If HRW asks you for a decimal, then you guys can round accordingly. Okay. So that is the sum of the first 5 terms. And we'll continue with more examples tomorrow.